This is the Chem 1 lecture over nuclear decay chains. So we've been talking about radioactive decay and elements like uranium that will release an alpha particle and become plutonium, for example. But plutonium itself is still radioactive, so it's not done decaying. So plutonium will then eject a beta and become something else, which is still not radioactive, which will continue on and on and on, which is called a nuclear decay chain. So it's a chain reaction where the products of one nuclear reaction become the reactants of the next reaction, so on and so forth. So if you have the nuclei of a very unstable isotope, it's undergo a series of decays, not just one, but multiple decays until it becomes a stable isotope. And so you have that definition written. What elements do this? These very large unstable ones, uranium, thallium, neptunium, all of these big ones are going to undergo some sort of decay. So this looks kind of scary, but it's really not anything new. I'm actually going to kind of skip this slide because it's hard for me to write on this. I'm going to add a new blank one, but you have this in front of you. So we're starting with uranium-238. So uranium-238, and its atomic number is 92. Just to review for your quiz tomorrow, the number on the bottom is the number of protons, which is equal to, is also known as the atomic number. The number on top is the mass number, not the atomic mass, the mass number, and is equal to what? Protons plus neutrons. This entire thing is called a what? Begins with an I. Isotope. An isotope is the same element that has a different number of neutrons. Now, the first thing it says we're going to do is undergo alpha decay. And we all know, I'm going to write it over here, an alpha particle is 4, 2, alpha. And if it's undergoing alpha decay, that means it's ejecting it. It's losing that. So an alpha particle is made of 2 protons and 2 neutrons. So if it loses 2 protons, what's going to happen to my atomic number of 92? It's going to go down by 2. It's going to become 90. Now, if it loses 2 protons and 2 neutrons, what's going to happen to my mass number of 238? It's going to go down by 4, so it becomes 234. How in the world will I know what element this is? Periodic table, because the atomic number right here, 90, identifies that element. So I'm going to go to my periodic table, and I find that element 90 is thallium, TH. The next thing it says it undergoes is beta decay, okay? So here's the beta. Remember, a beta particle is 0, -1. It occurs when an electron is ejected from a neutron, making the neutron into a proton. So, a neutron becomes a proton. What's going to happen to my number of protons if I just made a proton? It's going to go up by 1. Now, my mass number, which is protons plus neutrons, I lost a neutron that became a proton. It's going to stay the same, 234. And you can look up what element 91 is, and it's Pa. And then the next thing it undergoes, so on and so forth, and you can keep going until you end up, I'm going to jump back to this slide, you end up with a stable element. Now remember, anything above 82 is unstable. So very often, not always, but very often, you end with element 82, lead, in these nuclear decay chains. Now, real quick, what happens with gamma? I know it's not gamma that happens next, but let's say it's gamma radiation that's released next. Remember, gamma is 0, 0. So what is it going to do? Stay exactly the same. It's just releasing pure energy in that step. Now, you'll notice that this picture, it's like left and right and right and left and showing things like that. Well, really what it is the arrow points this way if the atomic number goes down. The arrow points this way if the atomic number goes up. I don't really care if you do that or not. Okay, that's technically correct, but with the space you have and things, it doesn't always work. So feel free, let's do the first couple parts of one of your homework problems together. Flip it over. Feel free to just put it in a nice, pretty straight line. So what's the element we're beginning with? Uranium-238? 235. So I know that since it's uranium, it's got to be an atomic number of 92 based on the periodic table, right? And what's the first kind of decay it's going to undergo? Alpha. At this point, once you draw that alpha, cross it off on that list. The number one mistake kids make in nuclear decay chains is like if it's like an alpha, 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 like 4 alphas in a row, they don't count the number of alphas they'll do and they'll do like 5 and they'll end up with the wrong product. So I suggest as soon as you write the alpha over the arrow, you go and cross it off and be like, done. I've done that alpha. Just so you can keep track of which step you're on. Or count the number of particles and count your number of arrows just to make sure you have the right steps. So losing an alpha, we're losing 2 protons, dropping this down to 90. Losing 2 neutrons and 2 protons, dropping this down to 231. And this becomes TH. What's the next process we undergo? Beta decay. Alright, now that I've written it, cross it off so we know we've accounted for it. In beta decay, that electron is ejected, turning a neutron into a proton. So I increase my number of protons, but my mass number is going to stay the same, and it becomes element PA. What's the next one we undergo? Alpha. And you keep going, and if you have to go to a next line, that's fine, until you get your final element and you put it in the box. Your final isotope, excuse me, and you put it in the box. Any questions about nuclear decay chains?